All right, we are back in action. We are down the rabbit hole. It's like part 4, like part 18. I'm not even sure anymore. Um, and we've got our hello world input wave where I say hello world. We put it in here. We have it in the time domain. We put it in the frequency domain. Then we actually run a little high pass filter on it. And we're like, okay, cool. We made some neat plots of some voice signals. Now what? Who cares? Well, here's what we can do. So we've run it through a filter. Let's put it back into the time domain, and let's put it back into a wave file, and let's see if we can like hear a difference or like hear something cool, or maybe it's like the worst sounding thing ever. But why not? Let's go do that, because that's what we're trying to do here. We're trying to explore and learn together. So what we need to do at this point is basically convert it back. We want to convert, we have this thing in this time domain, or we have this thing in this frequency domain, and it's got those crazy complex numbers in it. And we need to get it back into a real world thing. So really what we're going to do is we've passed it through. We've got this H signal. And really what we want to do is I'm going to use lowercase h. And we want to say inverse. We want to inverse that fast Fourier transform. And we want to operate that on big H that we just passed through this filter. So maybe I should. And then after that, what we want to do is we actually just want to like write that back to our little folder here. So we'll just, how we did the read earlier. In this case, we're just going to do the write. And I'm going to set it up here, and obviously it's not going to work yet. I'll get into how it works. Let's give it a title. Let's call it like filtered. We'll call it high pass filtered. And it's a wave file, so we'll call it .wave. And you recall, like when we pulled the data out originally, way up here, we captured the sampling frequency and the channels. So in this case, we probably need, if we're going to sample it back, if we're going to make that wave file again, we probably need that information. So thank goodness we saved that. So we'll send back that. And for right now, I'm going to leave it like that. Everything's not right for a number of reasons, but let's just go back and make sure we understand what's going on here. So right here, I've called this function the inverse fast Fourier transform. If you come all the way back up here, we've got NumPy, but we only imported, we were pretty lazy, or pretty, maybe not lazy, but we only pulled in what we needed to for the most part. Really, that's really all you should do. Pull in only what you need, nothing more. Take only what you need. In this case, I think we want to put this back. We want to do IFT. We just want to import that as well. We already saw this decremented down. There were already a number of red flags. We just reduced the number of red flags. So cool. So we want to make sure we add that. And whoop. Already going too far. So now we've got H in here. We're pretty confident we can use the inverse fast Fourier transform. And then we're just going to write it here. And then as I recall earlier, as we were up there, the other thing is we haven't even passed our signal here. So we have that H signal. That's why that was in gray there. So we're gonna write to this file. We're gonna call it this. We're gonna send in the sampling frequency, and then we're gonna send in our time domain. We're gonna say, hey, write this as a wave function. And of course, since we only took what we needed, we only brought in the read. So let's bring in the write. And hopefully that makes that thing go away. Okay, so now we just got the 25 crazy warnings. Some of these are obnoxious. Maybe we'll get into that later, but maybe that, never mind. Let's move on. So now we got everything. We got nothing, no red flags. We're going to convert this back to the time domain. We're going to write it into this function. It should produce a wave signal, or not a wave file that we should be able to play in our wave, or in a wave player. And we should be able to hear me say whatever silly thing I said in "Hello World." So let's go ahead and execute that. Actually, before we do that, let's do one other thing. So we're filtering out this low pass frequency, or we're filtering out a low frequency, 75 hertz and lower. We're just flattening that out. Let's make it more interesting. Let's set that a little bit higher. Let's do everything. Remember I said, maybe you don't, I don't even remember I said it, but 440 was a very interesting frequency musically. So all I'm going to do is we're just going to flatten everything out below 440. And I think we're going to actually just produce like the worst sounding thing ever. But I bet we still hear some things from the original where we can kind of tell it's the original, but we can also tell like, hey, we did a lot of damage with this silly filter. So let's just execute that and see if everything runs. I'm sure something will blow up on me. There's our time domain. There's the original frequency domain. Here's the left side of it. Here's the right side of it. Now we've gone through our filter, and you can actually kind of see that there. And now you can see we really flatten that out. Everything below 440. We still got some pretty good signal here. That's kind of interesting, kind of cool. And hopefully the reflection looks the same because we know how to code. And oh no, it blew up. Okay, so man, why'd it blow up? Okay, now we gotta go figure this out. This probably took me a fair amount of Googling. Actually, I don't think I had to Google that much. You just kind of wonder what it did here. So the data type, you got to pay attention to your data types. Right now we're trying to pass into the write function just the straight conversion, the inverse transform, and then we're trying to pass that right into the write. Not totally what you need to do. Turns out what you need to do is this craziness, as type, and then we're going to use np. So numpy, np is my numpy thing that I imported, and then we need the int 32. Okay, so now what we're saying is we kind of need to cast that as a 32-bit integer, and np does that for us. So we're taking all the data that we have in H that we've converted back into the time domain. It should all be real numbers. Maybe we'll go check that here in a second. But that should put it all back into how we need it, and this thing won't blow up again. So let's run it. Time domain, all the frequency domains. I'm just going to power through and reflection of that. Complex warning, casting complex values to real. Okay, so it's done a bunch of stuff, but the bottom line is it kind of put everything back. There's no perfect way to do that, right? We converted to a different domain. We did some stuff. We're trying to get back. We've obviously disrupted things, but now we're seeing HP filtered wave. So let's see if we can go hear that. Let me hide this. Let's go back into our folder. Here's our filtered. So I'm just going to open this. So we'll be able to listen to this one right next to this one. So we've got our filtered right next to that. And let me, because I'm talking on the microphone, I got to like unplug it here and then we'll play it. And so I'll play it a couple times, then we'll stop the video.
and I'll say hello world, and I'll say hello world, and I'll say hello world, and I'll say hello world.
Okay, so you probably heard quite a little bit of a difference there. Like I think it was fairly dramatic. Probably not the best sounding filter that we could have applied, but that's pretty significant. I think what we just did. So we recorded. I recorded my voice. You could do it too. We pulled that into Python. We manipulated it. We took it from the time domain. We took it into the frequency domain. We got rid of some of the frequencies, the lower end of the frequencies, and then we put it back into the time domain and we wrote it to a WAV file. So we did this little filter thing. It made it sound super weird. We keep in mind we only preserve the higher frequencies, and probably maybe some of the worst frequencies. I think it was still audible. You could still hear what we were saying or what I was saying, but kind of sounded different. Kind of interesting. So we'll stop it there. Thanks.